right, we're back and we're going to this time talk about how we use the law of cosines. So we just talked about where it comes from and how we get it. So let's recap and write our formula. So if we have the triangle on the left, ABC, our formula is a squared equals b squared plus c squared minus 2bc times cosine A. Now, there are technically three ways we can write this, but they all are really the same formula, depending on which sides and angles you're talking about. So we could also write it as b squared equals a squared plus c squared minus 2ac times cosine of b. I want you to look at that for a second and think if you see a pattern. Hopefully you do. So let's write that third form. We're going to have c squared equals the squares of the other two sides. So in this case, that would be a squared plus b squared minus 2 multiplied by the product of those other two sides. So AB times the cosine of the opposite angle, C. All right, so all three of these, they're the same formula. It doesn't matter which one of these is A, B, and C. We could rewrite this and say that this was A, this was B, and this was C if we wanted. So it's very relative, so all of these are the exact same formula. We can just think about them differently to help us out, but if you understand and notice the pattern that's happening, it doesn't actually matter what you use. All right, so I want to say really quick, we use the law of cosines for two different situations. One of them is when we know all three sides of the triangle. If we know all three sides and we want to find an angle, we would use the law of cosines. We also use it when we know two sides and the included angle, and we want to find the opposite side of that included angle, okay? So when I say in this case SSS and SAS, this has nothing to do with triangle congruency. I know it looks the same. It's not the same at all. I'm using it for when I have three sides or when I have two sides and an included angle, all right? And so you'll see both of those situations in the examples we're going to do, okay? So for our first example, we are going to just draw yourself a triangle. It doesn't actually matter what it looks like. It doesn't have to look like mine. Whoops. Well, I thought I could make that bigger. Apparently I can't. That's okay. Okay, and so as we usually do, I'm going to name this ABC. And I'm going to say that side BA is 20, side CA is 12, and angle A is 40 degrees. And our goal is to find the length of side A, side little a. So that right there is what we want to find. Okay, so we're going to use our law of cosines and just plug values into the formula. So again, the formula is a squared equals b squared plus c squared minus 2bc times cosine A. So we'll have a squared equals b squared is 12 squared plus c is 20 squared minus 2 times 12 times 20 times the cosine of angle A, which is 40. Okay, now this piece right here, you can plug that entire thing into your calculator all at once with not a lot of complexity if you have a calculator that can do multiple operations simultaneously. If you're using a calculator that can only do one operation at a time, then it's not going to work. But if you have most scientific calculators that can do multiple operations at once, this will work. And you can plug that entire thing in all at once, and I actually suggest you do, because that's going to make it that your answer is as accurate as possible. So when we do that, we're going to get a squared is approximately 176.3. Okay, so if you haven't already, go ahead and plug that into your calculator and make sure you get the same answer when rounded. And then we don't want a squared. That's not our final answer. We want to know a. So, oh goodness. We're going to square root both sides. And when we do that, we'll find that a is approximately 13.3. Okay? So that's an example when we have SAS, this right here. We had two sides and we had the angle in between those two sides so that we could find our third side, our opposite side. Okay, so our second example is going to be an example where we're going to have all three sides. And we want to find an angle. And if you have all three sides, you can find any angle using it. It doesn't actually matter. Okay, so we're going to draw another triangle. Okay, and once again, A, B, C. And in this case, we are going to say that side little a is 12, side little b is 18, and side little c is 9. And our task for this problem is to find the largest angle. So it's not any angle in particular, but we're going to have to do a couple of things to find what our biggest angle is. Okay, and from what we've talked about the triangle inequality theorem, we actually already know what the largest angle is. We're only going to have to do this once. We're not going to have to solve for all three angles because we can look at our side measures to figure this out. Since AC, or side little b, is our longest side, we know that angle B is going to be our largest angle. So that's what we're going to use when we do this. So we're going to use our law of cosines. B squared equals A squared plus C squared minus 2AC times the cosine of B. And in this case, big B is going to be our variable. So let's plug in each of those values. It is really, really, really important that we start with our 18. If we have any other number besides 18 on the left-hand side of our equal sign, we will not get the correct answer. It has to be the side that is opposite the angle we are trying to find. So we'll have 18 squared equals 12 squared plus 9 squared minus 2 times 12 times 9 cosine B. Now, I want to stop and point something out that is very, very important. Probably the most common, I'm not even going to say probably, I'm going to say definitely, the most common mistake that is made when students, or even adults, honestly, solve problems like this is they say, oh, there's something really nice there. I'm just going to take this entire piece right here, and I'm going to put it in the calculator, which would be really nice, but you cannot do that. Do not, under any circumstances, put that in your calculator and then move on from there, because your answer will 100% of the time be wrong. And the reason for this is this right here. You have 2 times 12 times 9 times cosine B, and over here you have a minus. Think about the order of operations. What comes first? Multiplication. Multiplication must come before subtraction, so you must multiply the 2 times 12 times 9 times your cosine of B before you subtract it. So since we don't know cosine of B, we just can't do that altogether. We have to simplify one piece at a time, okay? So this is what this will look like. We're going to simplify 18 squared. We'll start there. 324 equals, and then what we're going to do is we're going to simplify this part. This piece we can simplify all at once because it's just addition. So 12 squared plus 9 squared, if you throw that in your calculator, you're going to get 225. And then we keep our minus, and then we can do this piece all at once in our calculator because it's all multiplication. And multiplication, it doesn't matter how you group it. That's the associative property. So 2 times 12 times 9 is 216. And then we keep our times cosine B. Okay? So now what we're going to do is the way to think about it is think about as if this piece were an x. So it's as if you were doing 225 minus 216x. You can't do 225 minus 216 because they're not like terms, okay? So that's kind of what's happening here. So the next piece that we're going to do is we're going to subtract 225 from both sides. So now we will get 99 equals negative, don't forget that negative. That's another very common mistake. Don't just ignore that negative. It is important. It will change your answer. So negative 216 cosine B, and cosine B is our variable. And then to solve for our variable, we're going to divide, because that's the opposite of multiplication, or the inverse of multiplication, by negative 216. So what we're going to have left over is cosine of B is equal to 99 over negative 216, okay? Or 99, or negative 99 over 216, because it doesn't actually matter where that negative goes. So then to find B, since we have cosine of B, we're going to use the inverse cosine. So this piece right here is what you're going to plug into your calculator. The inverse cosine of negative 99 over 216. And when you do that, you should get that B is approximately 117.3 degrees. So as you can see, Finding an angle is definitely more labor intensive than finding a side. Finding a side, we can plug in a big giant piece into our calculator all at once and then take the square root, and it's super straightforward. It is not that straightforward with finding an angle. So we need to be really, really careful that we pay attention to the order of operations and solve this one piece at a time, and don't combine things that we're not allowed to combine. Okay, so be really careful when you find those angles.